Welcome dear student and Jai Swaminarayan. In the previous video, we were discussed the first 10 question of the exercise of chapter number 5, laws of motion. Dear student, in this video, we will discuss the remaining question of the exercise of chapter number 5 from the question number 11. So dear student, let us start with the question number 11. A truck starts from the rest and accelerates uniformly at a 2 meter per second square. Here the truck starting from the rest. That means the initial velocity of the truck is a 0 and accelerate uniformly. Uniform acceleration is given to you 2 meter per second square. At the t is equal to 10 second, a stone is dropped by a person standing on the top of the truck 6 meter high from the ground. A person standing on the top of the truck which is the 6 meter height from the ground. So distance from which the stone will be dropped is given to you. What are the velocity and the acceleration of the stone at t equal to 11 second? Neglect the air resistance. So here the truck is starting from the rest. That means the initial velocity of the truck is 0, right? Here the initial velocity of the truck v0 is equal to 0 and moving with the uniform acceleration means constant acceleration a is equal to 2 meter per second square at the time t is equal to 10 second. Now first of all we need to calculate the velocity of the truck at the time t equal to 10 second. Now at the end of the 10 second, the velocity of the truck can be easily calculated with the help of the first equation of the motion. V is equal to V0 plus AT. So here the initial velocity V0 is equal to 0, acceleration A2 and time t is given to you 10 seconds. So the velocity of the truck after 10 seconds is 20 meter per second, right? Because here at the 10 second the stone will be dropped. So as the stone is dropped, the velocity of the truck is at 20 meter per second. Now here we want to find the velocity of the stone at the time t equal to 11 second. Now since the stone moves with the constant velocity in the horizontal direction, hence there will be a no change in the horizontal component of the velocity. So here the horizontal component of the velocity remains constant. So we take the x component of the velocity of the stone Vx is equal to 20 meter per second. Now we need to find the y component. So during the y direction, right, the stone will move in the downward direction. So when the stone is allowed to fall freely, initial velocity of the stone v0 is equal to 0. So at the end of the 11 second, that means the after 1 second when the stone will be dropped, t is equal to 11 minus 10 is equal to 1 second. Y component of the velocity vy is equal to v0y plus ay into t. So here v0y is equal to 0, right? Ay constant acceleration. When the stone drop in the downward direction, the downward acceleration remains constant and it is equal to 9.8. So ay is equal to 9.8 and t is a t. So y component of the velocity is 9.8 meter per second. So resultant velocity, the x component of the velocity remains constant because here the projectile motion of the stone, the horizontal component of the velocity remains constant, right? So Vx is equal to 20 meter per second and vertical component of the velocity Vy is equal to 9.8 meter per second. So resultant velocity of the stone V is equal to Vxi plus Vyj. We can calculate 20I plus 9.8j and the magnitude of the velocity is under root of 20 square plus 9.8. If you calculate that, we get 22.4 meter per second. And the direction of the velocity, we can calculate theta is equal to 10 inverse 9.8 divided by 20. Right? So understand dear student? Now, second part is calculate the acceleration of the stone. So here the stone moves with the in the horizontal direction with the constant velocity. Hence, its acceleration in the horizontal direction is 0. Right? So during the motion of the stone, the horizontal velocity of the stone remains constant throughout the motion. So the horizontal component of the acceleration is 0. So acceleration The vertical component of the acceleration is acceleration due to gravity. So acceleration of the stone A is equal to vertical component of the acceleration, and it is equal to the acceleration due to gravity G, 9.8 meter per second square. Understand, dear student? Now question number 12. A bob of a mass 0.1 kg hang from a ceiling of a room by a string of a 2 meter long is set into oscillation. Like also in this figure, a bob of a mass 0.1 kg is hang from the ceiling of the room by a string of a 2 meter. So here the length of the string is given to you 2 meter. Mass of the bob is a 0.1 kg. Now it is free to oscillate in the horizontal direction. The speed of the bob at its mean position is 1 meter per second. So at the lowest position, the speed of the bob is 1 meter per second, and we can consider the velocity of the bob at the mean position. That means that at the lowest position is a 1 meter per second. What is the trajectory of the bob if the string is cut when the bob is at one of its extreme position and at the mean position, right? So at the mean position, when the string is cut when the bob is at the mean position, what is the trajectory of the bob? And when the string is cut when the bob is at extreme position, that means at the highest position, what is the trajectory of the bob, right? Now here the bob of the is considered as a sphere as shown in the figure, right? If you consider the sphere of a is oscillating like this according to the simple pendulum, right? Now when the sphere is at the position B, that means its velocity is 0, right? So when the position is when the bob is at an extreme position, maximum position, the velocity of the bob is 0. Now when it break at a point B, due to the gravitational force F is equal to mg and it is in the downward direction, the trajectory of the bob is in the downward direction, right? Now when the sphere is at the position A, that means at the mean position, the velocity of the bob is a maximum, right? And it is a 1 meter per second, right? It is a 1 meter per second. So here at the mean position, at the lowest position, the horizontal component of the velocity is the 1 meter per second. Acceleration of the sphere is acceleration due to gravity 10 meter per second. So we consider that the sphere behaves as a projectile motion. So when the string is cut at the extreme position, the trajectory of the bob is in the downward direction, and when the string is cut at the mean position, or we can say that the lowest position, the path of the sphere is a projectile motion, or we can say that the parabola, right? Now question number 13, important for the JEE and NEET also, right? A man of a mass 70 kg stands on a weighing scale in a lift which is moving upward with the uniform speed of the 10 meter per second, downward with the uniform acceleration 5 meter per second square, upward with the uniform acceleration 5 meter per second square. What would be the reading on the scale in each case? Now fourth question is, what will be the reading if the lift mechanism fail and it hurled down freely under the gravity? So here, dear student, mass of the man is given to you 70 kg and standing on the weighing scale. So weight of the person is mass of the person is 70 kg. We take the acceleration due to gravity 10 meter per second. What will be the weight of the person? How we can calculate the weight of the person? The weight of the person W is equal to mg. So the weighing scale measure the weight of the person is a 70 into 10, 700 Newton. If the weight is if the lift is a stationary, right? So if the lift is a stationary, the weight of the person measured by the weighing scale is a 700 Newton. Now when the lift is moving with the upward direction with the uniform speed 10 meter per second. So when the lift moves in the upward direction, with the constant velocity 10 meter per second. So Newton was said that the stationary object and the object moving with the constant velocity is the same situation, right? So when the lift is moving with the constant velocity, the acceleration of the lift is zero. The pseudo random acceleration of the lift is a zero, right? So when the lift is stationary and the lift is moving with the constant velocity, in the both the case the pseudo acceleration is zero and the weight of the person recording by the weighing machine is a W is equal to mg. So W is equal to mg, 70 into 10, 700 Newton, right? Now when the lift is moving in the upward direction, the pseudo acceleration produced in the person is in the downward direction, and when the lift is moving in the downward direction, the pseudo acceleration will be produced in the upward direction, like this. See here, like this. When the lift is stationary, right, its pseudo acceleration will be zero, right? Or when the lift is moving with the constant velocity in the upward direction or in the downward direction, in the both the case the pseudo acceleration will be zero and the weight of the person measured by the weighing scale is W is equal to m into g. Now let us take the another situation when the lift is moving with the some constant acceleration in the upward direction. When the lift is moving with the constant acceleration in the upward direction, say the acceleration of the lift is a, right? The pseudo acceleration will be produced in the main in the downward direction, right? Here the pseudo acceleration will be produced in the downward direction. Same amount of the pseudo acceleration will be produced in the downward direction. So on the person, the two type of the forces acting on the person. First, its own weight is in the downward direction mg, and second, due to the pseudo acceleration, the force acting on the person m into a. So total weight of the person is increased by mg plus ma by an amount ma, right? So understand, dear student. Now similarly, when the lift is moving with the acceleration in the downward direction, the pseudo acceleration produced in the upward direction and the weight of the person is decreased by a factor of a ma, right? Let us consider the second situation when the lift is moving down with the acceleration 5 meter per second. The pseudo acceleration will be produced in the downward direction. So here when the lift and the person is standing on the weighing scale on the lift, and when the lift is moving in the downward direction, the weight of the person mg in the downward direction, but the pseudo acceleration will be in the upward direction. So weight of the person is decreased by a factor ma. So the weight recorded by the weighing machine m w is equal to mg minus ma, or we can say that the m into g minus a. So here the mass of the person is given to you 70, g we take a 10, and the acceleration is a 5 meter per second. So 10 minus 5 we get the 350 Newton. So here the weight of the person recorded by the weighing machine when the lift is moving with the constant acceleration in the downward direction, the weight of the person is recorded by the weighing machine is a 350 Newton. And if you calculate the mass from that, the mass of the person is a 35 kg, right? Now dear student, let us take the third situation when the lift moves in the upward direction with the acceleration 5 meter per second, right? If we considering a lift is moving in the upward direction with the acceleration a is equal to 5 meter per second. Here the weight of the person here the weight of the person is always in the downward direction mg, but when the lift is moving upward direction with the pseudo acceleration a, the pseudo acceleration also in the downward direction, and the weight of the person is increased by a factor ma. So weight of the person recorded by a weighing machine is mg plus a, right? So 70 plus into 10 plus 5, we get a 1050 Newton, right? So dear student, understand, when the lift is stationary or moving with the constant acceleration, the weight of the person recorded by the weighing machine is same, W is equal to mg. But when the lift is moving in the upward direction with the constant acceleration a, the weight of the person is increased by a factor ma. So the weight of the person W is equal to m into g plus a. Similarly, when the lift is moving in the downward direction with the constant acceleration a, the weight of the person is decreased by a factor ma. So weight of the person is m into g minus a. And last point is, when the lift is falling freely, the acceleration, pseudo random acceleration is equal to the gravitational acceleration g. So the weight recorded by the person mg, a, we take a is equal to effective gravitational acceleration g minus a, we take a is equal to g. So effective acceleration is g, right? 0, right? So the weight of the person is recorded by the weighing machine is a 0, and this is called the weightlessness, right? So now dear student, we'll take a question number 24, which is similar to the question number 13. A monkey of a mass 40 kg climbs on the rope as shown in the figure, which can stand a maximum tension of the 600 Newton. In which of the following case will the rope break the monkey, right? A climbs with the acceleration of a 6 meter per second, climbs down with the acceleration 4 meter per second square, climbs up with the uniform speed 5 meter per second square, and falls down the rope nearly freely under the gravity, right? So here the maximum tension force can withstand by the rope is a 600 Newton. Now, if the monkey is climb up with the acceleration 6 meter per second in the upward direction, the pseudo acceleration will be produced in the downward direction, and the weight of the monkey is increased. So, if the weight of the monkey is greater than the maximum tension, the rope break by the monkey, right? So, here first of all, we consider that when the monkey moves upward with the acceleration a, right? So here the weight of the monkey is in the downward direction mg, and tension force in the upward direction. So if the weight of the monkey is greater than the tension force, the rope will break, right? So here the when the monkey is climb up with the acceleration a is equal to 6 meter per second. So here the pseudo force acting on the monkey is in the downward direction, and the weight of the monkey is increased by a factor ma, as we were discussed previously in the case of the lift. So the tension force, the weight of the monkey W is equal to m into g by g plus a. So the total weight of the monkey is 640 Newton. But here the maximum tension force withstand by the rope is a 600 Newton. So here the weight of the monkey is 640 Newton, which is greater than the maximum tension. So the rope will break, right? So second case is when the monkey moves in the downward direction with the acceleration of the 4 meter per second square. So in the second scale, right, when the monkey is moves in the downward direction with the acceleration 4 meter per second square, the pseudo acceleration will be in the upward direction. So the weight of the monkey is decreased by a factor ma. So the weight of the monkey is m into g minus a. So we get weight of the monkey is 240 Newton. So here the weight of the monkey is less than the maximum tension. So the rope will not break, right? And third case when the monkey moves in a upward direction with the constant velocity, the pseudo acceleration is 0, right? So if the monkey moves with the constant velocity or stationary, the pseudo acceleration is 0, and the weight of monkey W is equal to m into g. So we get a 400 Newton. So in this case also, the weight of the monkey is less than the maximum tension, so the rope will not break, right? And the last case is that when the monkey is falling freely due to gravitation, its a pseudo acceleration will be g, right, and it is in the upward direction. So the weight of the monkey is W is m into g minus a. So we get a 0 Newton. So here the monkey is the weightlessness condition. Tension in the rope is a 0. So rope will not break, right? So when the monkey is climb up with the acceleration 6 meter per second square, the rope will break. In all other case, the rope will not break, right? Understand, dear student, both the example question number 13 and question number 24 is similar, and these two question is important for the JEE and NEET also. So now, dear student, we will see the question number 14. Figure shows the position time graph of the particle of a mass 4 kg. Mass of the particle is given to you 4 kg, right? And in the figure, position time graph is given to you. What is the force on the particle for the t less than 0? So before the force is applied, what is the force on the particle when the time t less than 0, time t greater than 4 second, and between 0 to 4 second, and also calculate the impulse at the t equal to 0 and t equal to 4 second. So here the mass of the particle is given to you and the position time graph is given to you for the particle, right? Mass of the particle is 4 kg and position time graph. So first case, so when for the t less than 0, the object is stationary, hence the force acting on it is a 0. So at the time t is equal to 0, or when the before the time t equal to 0, when the t is less than 0, right, the force, the object is stationary. So from this position time graph, if we consider the position time graph t less than 0, it is a straight line, right, and straight line parallel to the time axis. So for that, the we can say that the object is stationary, and if the object is stationary, we can say that the force acting on the object is a 0, right, like this. Now second, from the position time graph, for the time t is greater than 4 second, the graph is parallel to the time axis. So beyond 4 second, t greater than 4 second, graph is a parallel to the time axis. And when the position time graph is a parallel to the time axis, we can say that the object is stationary. So in both the first two cases, the force acting on the object is a 0. So when at the time t less than 0, the object is stationary, and at the time t greater than 4 second, the graph is a parallel to the straight line and the object is stationary. So in both the case, the force acting on the object is a 0, because when the object is stationary, we can say that the force acting on the object is 0, right? Now in the third case, between the 0 to 4 second, right, during this, object covers the equal distance in the equal interval of the time. Hence, we can say that the velocity of the object is constant, right? So, during t equal to 0 to 4 second, the graph is a straight line linear. And when the position time graph is a straight line linear graph, we can say that the object moves with the uniform velocity. And when the object is moving with the uniform velocity, the acceleration of the object is 0, and if the acceleration is 0, we can say that the force is acting on the object is 0. So dear student, in all the three cases, right, the force acting on the object is 0. In the first case, the graph is a straight line parallel to the time axis, right? So we can say that the object is stationary, and for that we can say that the force acting on the object is 0. Second, in the second case, time t greater than 4 second, right, the graph is parallel to the time axis again, and we can say that the object is stationary, and hence we can say that the force acting on the object is 0. And between t is equal to 0 to the 4 second, right, the graph is a straight line linear, and when the position time graph is a linear, we can say that the object moves with the uniform velocity. If the velocity of the object remains constant, right, object moves with the uniform velocity, the acceleration of the object is 0, and according to the Newton's second law, F is equal to m into a, the force acting on the object is also 0. Now second part, how we can calculate the impulse of the force at the time t equal to 0 and at the time t equal to 4 seconds. So what is the impulse of the force? The impulse of the force F in delta t is equal to the change in the linear momentum. So at the time t is equal to 0, the velocity of the object is a 0. And at the time t equal to t second, the velocity of the object can be calculated by a slope of the line OA. Right? So here the how we can calculate the slope of the line OA? Right? Y coordinate divided by x coordinate. So here the y coordinate 3 minus 0. We get a 3 divided by x coordinate, we get 4 minus 0, we get a 4. So the velocity of the object at the time t equal to t second is a 3 by 4, 0.75 meter per second. Now change in the linear momentum. Initial momentum is 0. So change in the momentum is equal to final momentum m into v minus initial momentum m into v0. So m, mass of the object 4 kg, final velocity 0.75 minus mass of the object 4 kg, initial velocity 0. So from that, if you calculate, the impulse of the force is a 3 Newton per Newton into second. Now similarly, you can calculate the impulse of force at a time t equal to 4 second. At the time t equal to 4 second, initial velocity is 0.5, and at the time t equal to after the time t equal to 4 second, the velocity of the object is 0 because the graph is a straight line parallel to the time axis. The object is stationary. So final velocity is 0. So the change in the momentum, and it is equal to the impulse of force, is equal to m into v minus v0. It is a minus 3 Newton into second. Understand, dear student, this question number 14, right? Now we will see question number 15. Two bodies of a mass 10 kg and 20 kg respectively kept on the smooth horizontal surface are tied to the end of the light scale. Here the surface is a smooth horizontal surface. So neglect the friction force acting on the block. So two blocks of a mass 10 kg and 20 kg are kept on a horizontal smooth surface are tied to the end of the light string. A force of a 600 Newton is applied to a first A and second B along the direction of the string. What is the tension in the string each case, right? So first consider is that consider the two block of a mass m1 10 kg and two second block of a mass 20 kg tied with the light string, and the force applied on the object of a 20 kg in the direction of the string. So F is given to you 20 kg, right? So what will be the tension produced in the string, or what will be the acceleration of the system of two block, right? So consider the free body diagram. What type of the force is acting on the object? Here the force F, external force F of a 600 Newton is acting on the object B in this direction, right? Tension force in the produce. So if we consider the free body diagram of the block M2, right? So here the block is moving in the direction of this, right? So the acceleration produced on the block M2 is in the direction of the force F. So here if you draw the free body diagram of the object M1, right? The free body diagram of the object M1 is like this, right? Tension force produced on the block, only one force is produced on the block, and it is a tension force, and block is moving with the acceleration A in the direction of the external force, right? So from this free body diagram of the block M1, if you write, the T is equal to M1 into A. So due to the tension force, right, the acceleration produced in the block M1, so you can write tension force produced in the string T is equal to M1 into A. So from this first equation we get the first equation T is equal to M1 into A. If you put M1 is equal to 10 Newton, we get T is equal to 10 into A. Right? Now consider the free body diagram of the second block. Second block has a mass M2. The forces acting on the second block is a force F in this direction, Another force act on the block is a tension force in this direction. And acceleration produced in the block is in this direction. So here the force F is greater than the tension force. So the acceleration produced in the direction of the external force. So from this free body diagram, if you write the equation, we get the F minus T is equal to M2 into A. So we get the second equation. F minus T is equal to M2 into A. So if you put the value, we get a second equation, right? Value of F is the 600 minus capital T is equal to value of M2 is a 20 into A. So here we get the two equation. By putting the value of capital T in the second equation, we get the acceleration, and from the acceleration we get the tension produced in the string. So by solving these two equations, we get the acceleration produced in the system of the block and the tension force in the string, right? So you can calculate by yourself also, and if you calculate this, solve if you solve these two equations, we get a tension force. So if you solve the above equation, you get the tension force produced in the string is a 200 Newton, right? Now second situation is that similar. So when the force is applied to the block of a mass m1 at a point A, right? So force direction of the force in this direction, the tension force produced in the string, right? And similarly, try to solve this example by drawing a free body diagram of the block of a mass m1. So here in the block m1, two forces acting on the block F and T, right? And the acceleration is in the direction of the force. So from the block m free body diagram of the block m1, we get the first equation, F minus T is equal to m1 into A. And from the free body diagram of the block m2, we get the equation T is equal to m2 into A. And by solving this equation, we get the tension in the string T is equal to 400 Newton, right? Now dear student, we take a similar example, question number 16, by solving with the help of the free body diagram. Two mass of the 8 kg and 12 kg are connected at the two end of the light inextensible string that goes over a frictionless pulley. Find the acceleration of the masses and the tension in the string when the mass are released. So here let us see the figure. Here the object of a mass m1 is equal to 8 kg is tied with the one end of the string. Object of the mass 12 kg is tied with the other end of the string, and the string is passing through the frictionless pulley, right? So obviously from the figure, the mass m of mass of the object 12 kg is moved in the downward direction, and the mass 8 kg block is moved in the upward direction. So by drawing the forces acting on the both the object and with the help of the free body diagram, we can calculate the acceleration of the system as well as the tension produced in the system. So let us consider the forces acting on the object. So on the object of a mass m1, the weight force m1g in the downward direction and the tension force produced in the string in the upward direction, and the object is moved in the upward direction, right? Similarly, the forces acting on the block of a mass m2, m2g in the downward direction, tension force produced in the block T in the upward direction, and the acceleration in the object is in the downward direction. So with the help of the free body diagram of the block of a mass m1, right? So equation of the motion, so m1g is in the downward direction, tension in the upward direction, and acceleration is in the upward direction. So here the acceleration is the upward direction, so we can say that the tension force is more than the weight force, right? So we can write the equation T minus m1g is equal to m1 into A. So similarly for the block m2, m2g is more than the tension force, so that the block is moving in the downward direction. So we can write the equation m2g minus T is equal to m2 into A. So by solving these two equations, we get the acceleration, right? By adding these two equations, T minus m1g plus m2g minus T is equal to m1 plus m2 into A, right? Here T cut out, we get the m2 minus m1 into g is equal to m1 plus m2 into a. So acceleration of the system A is equal to m2 minus m1 divided by m2 plus m1 into g. So if we put the value 12 minus 8 divided by 12 plus 8 into 10, we get the acceleration A is equal to 2 meter per second square. And putting the value of acceleration in any of the equation, we get the tension, right? T is equal to 96 Newton, right? So dear student, I hope that you understand all the question of the exercise explained in this video. Thank you very much for watching my video.